the traditional software engineering lifecycle is completely broken. If you are still spending 3 months drafting architecture diagrams, writing boilerplate authentication code, and manually configuring API endpoints just to validate a basic software idea, you are actively losing the race. In 2026, the gap between a monetization strategy and a live, production-grade application has narrowed to under an hour. We are no longer in the era of just writing code with an AI assistant. We have entered the era of autonomous software synthesis, where entire full-stack ecosystem engines are generated in a single session from a raw terminal prompt. Today, we are breaking down the exact blueprint to deploy a fully functional, database-backed web application using the ultimate modern developer stack, Bolt.new and Supabase, completely bypassing the traditional friction of local environments and server configuration. Let us get one thing straight. This is not about building another generic to-do list or a basic landing page that looks pretty but does absolutely nothing under the hood. We are building a high-utility, multi-tenant automated analytics dashboard that extracts data, processes it via background workers, and serves it through a sleek, responsive interface. Normally, a project like this requires a front-end engineer, a back-end developer, a database administrator, and a DevOps specialist. You are going to do all of it by yourself before this video ends. We start the clock with Bolt.new. The magic here lies in its full-stack web container capabilities. Unlike basic AI code generators that merely spit out fragments of code for you to manually copy and paste into an editor, Bolt runs an entire development server directly inside your browser using web containers. It initializes a full Vita development environment, sets up a Node.js runtime, handles package installations autonomously, and provisions files in real time. To kick off the build, we feed the engine a hyper-specific architectural prompt. We tell the system to construct a modern software-as-a-service dashboard featuring global state management, dark mode optimization, integrated charting libraries using recharts, and mock real-time data streaming hooks. Watch the terminal inside the interface. The AI does not just write the React component. It actively executes command line instructions, installs the necessary dependencies like Lucide React for iconography and Tailwind CSS for utility-first styling, and resolves version conflicts without human intervention. If an error occurs during compilation, the environment detects it, passes the stack trace back to the LLM core, and self-corrects the line of code instantly. Within 90 seconds, the front-end architecture is fully materialized. You can see the navigation sidebars, the interactive data tables, and the responsive grid layouts operating seamlessly. But a great front-end without a dynamic data layer is just an expensive PowerPoint presentation. We need a production-grade database that scales infinitely. That is where Supabase enters the pipeline. Instead of spending hours installing PostgreSQL locally, configuring user permissions, and wrestling with connection strings, we jump straight into the Supabase Cloud Console to initialize a new project instance. We create our data tables for users, subscription tiers, and system metrics. To connect our browser-based development environment to our cloud database, we extract the project API URL and the anonymous public service API keys from the dashboard settings. We jump back into our development workspace and inject these values directly into our environment variables configuration file. The workspace immediately reads the new parameters and initializes the backend client library. Now, every single interaction on our generated front-end is backed by a live, enterprise-ready relational database. We write the data fetching hooks to replace our mock data with real-time PostgreSQL database queries. We implement row-level security policies directly from the workspace to ensure that users can only read and write data that belongs specifically to the unique account IDs. The system is now reading, writing, and updating structured data seamlessly across the network. The skeleton of our empire is officially standing, the database is responding, and the interface is lightning fast. So your application architecture is fully built and the database is humming in the cloud. But if you take this raw build and ship it to paying users right now, your system will instantly collapse under the weight of real-world traffic, security vulnerabilities, and unmonetized resource consumption. Build speed means absolutely nothing if your deployment cannot withstand a basic web vulnerability scan or process an international credit card payment. We need to transform this raw code artifact into an absolute fortress capable of generating passive revenue on complete autopilot. The first critical layer we must implement is automated user authentication and access control. A security breach will destroy your digital brand reputation before you even get off the ground. We utilize the native authentication suite inside our cloud database stack to handle user sign-ups, secure password hashing, and session management. We instruct our development workspace to generate a clean, secure authentication gate component. This gate wraps our entire dashboard view, intercepting unauthenticated traffic and redirecting anonymous users to a secure login interface. The app now handles JSON Web Tokens autonomously, storing session states securely inside the browser storage and appending validation signatures to every outbound database request. With security locked down, we shift our focus to the lifeblood of any digital operation, monetization. We integrate Stripe for seamless payment processing. Instead of writing complex server-side billing logic from scratch, we leverage pre-built webhook endpoints and billing portals. We map our database subscription tiers directly to the billing product identifiers. When a user upgrades their account on our dashboard, the system routes them to a secure checkout page, processes the transaction, and fires an instantaneous webhook event back to our database to unlock premium features. This entire loop operates without a single line of manual payment processing infrastructure written by hand. Now, let us talk about deployment and scaling. Keeping an app running on a local development server or confined to a browser workspace is useless. We need our application accessible globally with sub-millisecond latency. We connect our code repository directly to Netlify or Versal for continuous integration and automated deployment. Every single time a modification is committed to the main code branch, the Edge network automatically triggers a production build pipeline. It optimizes our JavaScript bundles, minifies our Tailwind CSS styles, compresses our static image assets, and distributes the entire application across a global content delivery network. Your application is now live on the public internet, completely optimized for performance, and capable of handling thousands of concurrent users without breaking a sweat. To ensure we maintain complete visibility over our operational scaling, we implement lightweight telemetry and performance monitoring hooks. If a database query takes too long or a payment webhook fails to process, the system automatically logs the event and flags the anomaly. You do not need to babysit your system. The telemetry architecture keeps watch for you 24 hours a day. Look at what we just accomplished in a single session. We bypassed weeks of manual engineering gridlocks. We eliminated local environment setup headaches, avoided manual database hosting configurations, and bypassed complex payment gateway development. By orchestrating automated workspaces, cloud relational databases, and edge hosting networks, you have transformed a raw concept into a secure, monetizable, production-ready software asset. The barrier to entry has completely evaporated. The only variable left in the equation is your execution speed. Stop overcomplicating development, stop hiding behind excuses of lacking a technical co-founder, and start deploying.
Thanks for watching Zero Click Report. Click the icon to subscribe.